Yesterday we were looking at the equation. So I said, I started class by saying there's three equations we work with. So this, and that equation so far. So that equation is the factor form. This is the equation that we use in order to find our roots immediately. Okay? And when we solve quadratic equations, that's basically what we're trying to do, is we're trying to solve our roots every time. So our roots, zeros, x-intercepts, whatever you want to call them. So 7.5 deals with doing exactly this, but by factoring. So we spent piles of time factoring last year, and all of that was for this unit right here. Okay, so we need to get back to doing what we do when it comes to factoring. So taking a look at the first example question, I have 0.125 x squared minus 0.875x. Now the first step in solving all of these questions is to get it to equal 0. So I'm going to add 1.5 and get it equal to 0. So that's the first step in solving any quadratic equation. All right? Now, because it's equal to 0, I am going to do my best to factor out whatever my a value is. And again, your a value is always found in front of the x squared. So instead of factoring it out, which is one of the processes that we do, we're actually just going to simply divide it out. Because whatever I do, because it's an equal sign, whatever I do to the left side, I can do to the right side. So I'm going to divide everything in this equation here by 0.125. So that's going to leave me with x squared minus, is it 7? Yeah, thanks. 7x and plus 12, which is equal to 0. So the first step in the process is to divide everything out by the a value. Now I have it into a manageable, factorable equation. Two sets of brackets. 0 factors of x squared, x and x. Negative 3 and negative 4. Therefore, x is equal to 3 and 4.
Do we have to put, would it be like this one answer, would it be both?
It's both. Now, remember, there is a possibility that it can be one answer. In all of these equations, there is a possibility that we have 2, right? It's a possibility that we have only 1, and then there's a possibility that we have 0 roots. So that is potential in every question. Okay? Any questions so far? Now, what happens if we don't have something that's factorable? So, or not factorable, sorry. What happens when we don't have an a value that comes out nicely? Plus 49. Okay. So I'm going to show you, that first example worked great because it came out and then it was easily factorable. It was all whole numbers. Everything was hunky-dory. Okay. Now, look at this equation here. Can I divide 42 by 9 nicely?
No.
No, can't. Can't divide 49 by 9 nicely either. So the option to divide it out isn't going to work. So now I have to decide, how do I factor this? Well, there's the long way to factor it, which I'll show you. And then there's the way in which you have to have the ability to recognize perfect squares. Is 9x squared a perfect square? Yeah. Is 49 a perfect square? Yes. So then what I'm looking at is this. Square root of 9x squared? 3x. And 3x. And the square root of 49? 7. 7. Okay. Okay? Now, it may not work out that nicely all the time, but in this case it did. 7 times 3x is what? 21x. 3x times 7 is?
21x.
When I add 21x and 21x, what do I get? 42x. Okay. Now, there is a way in which I can check this, so this is something you have not seen before, so I'm going to show you. There is a way in which I can check this right away to see if this method is going to work for me. And that is simply do this. I take the square root of a squared times the square root of b squared times 2. And it should equal my middle number. So the square root of 3x squared is, 9x squared was what? 3x, right? So that's 3x. Square root of 49 was? 7. And I times that by 2. 3x times 7, 21x. 21x times 2 is 42x. That gives me that middle. Therefore, all I have to use is my square roots here. Now, I'm not done with the question. I have to solve it. So I have 3x plus 7 equals 0. 3x equals negative 7. X is equal to negative 7 over 3. There's my solution. Now, George just asked, do I have both solutions in the last question? The answer is yes. What has occurred in this solution? I only have one, which means that where is the vertex of this graph? Where's the vertex of this graph?
On the x-axis.
On the x-axis, which makes that vertex, if it's on the x-axis, what's your y value on the x-axis? 0. Makes that vertex negative 7 over 3 and 0. Okay? Because there's only one root, which means it touches the axis and then goes in whatever direction it's supposed to. In this case, it'd be positive, it would open up. So if you were to graph this equation, which you can to check your answer, you'd see that negative 7/3 and 0 is your vertex. It's also the only root and the only solution to this quadratic. Okay, so far? Yeah? All right. Okay, we have one more scenario I want to look at, I think. Just give me a second. Oh, actually a couple more. What if I had this here? 9x squared minus 49 equals 0. What's the solution for this guy?
3x minus 7 and 3x plus 7.
Yeah, very good. Very good. That's a good pickup. Okay? 9x squared, perfect square? Yes? Subtract sign? 49 a perfect square?
Yes.
Difference of squares. Do you remember this from last year? If I have a squared minus b squared, that factors to a minus b, a plus b. Make sure you got a note of that. I don't see anybody writing this down. This is going to happen. You need to recognize difference of squares. Now, we can easily do that and go 3x minus 7, 3x plus 7 equals 0. Therefore, x is equal to 7 over 3 and negative 7 over 3. I do want to show you there is another way in which this question could have been done. And that is solve for x. So 9x squared equals 49. Divide by 9. X squared equals 49 over 9. How do I get x squared to become an x? Square root it. So when I square root that, what's the square root of 49?
7.
The square root of 9. I also add in plus minus on this. So why is that? When I take the square root of 4, actually let me put it the other way. What is 2 squared? 4. What is negative 2 squared? 4. So when I take the square root of 4, I can have plus 2 or negative 2 is your answer. The same way I can have the square root of 49 and the square root of 9 as 7 over 3, and it can be a plus or a minus. So those are 2 ways. But you have to. This is huge. That right there is extremely important. And as we get into grade 12, it becomes even more important. We do a lot of work in which we have to be able to identify perfect square, subtract perfect square. Your difference of squares. All right? And one last one I wanted to show you. I think. Yep. Okay. Let me think this through so I don't do the same one. Okay. 4x squared minus x minus 3. So the first thing I do, we talked about this last year. When it comes to factoring, what's the first thing that I look for? What is it? Greatest common factor. Very good. Is there a greatest common factor here?
No.
No. So I cannot factor the a out. So now I have to approach this differently. So there were 3 steps in which we looked at last year and how to solve this question, or how to factor it properly. First of all, I look at the product. The product is a times c. So in this case, I take my a value, which is 4, times my c value, which is negative 3, so that gives me negative 12. My sum has to be my b value, which is negative 1. So I need the factors of negative 12 that add to give me negative 1. So what 2 numbers do I multiply to give me negative 12 to add to give me negative 1? 4. What do you got? 3 and negative 4. Okay. Now, instead of putting negative x in there, I'm now putting 3x and negative 4x in replacement of it. So I'm going to write it like this. 4x squared minus 4x plus 3x subtract 3 equals 0. Okay? So I replace negative 1x with negative 4x, add 3x. Now, brackets. You remember this? No?
Yeah.
You don't know what to do next, Cameron? What was the first thing I told you to start with?
Greatest common factor.
Okay, so now you look in the bracket. Is there a greatest common factor between these two?
Yeah.
What is it?
2, 4,
4 what?
4x.
4x. So I take the 4x out of here, and that leaves me with x subtract 1. Right?
Mm-hmm.
What's the greatest common factor in this guy? 3. Take the greatest common factor out. I'm left with x minus 1 equals 0. Do you remember this now?
Yeah.
Okay? Now what's the greatest common factor between the two terms?
1, 1.
X subtract 1. So when I take it away from this guy, what am I left with?
4x plus 3.
4x, add 3, equals 0. x equals 1 and -3/4. There's my two roots. All right?
Can you please explain how do you get that last part?
Right here?
Yeah.
What value of x is going to make this bracket equal 0?
Oh, okay.
So basically what I do is I go x subtract 1 equals 0, and solve for x equals 1, right? And then here I have 4x plus 3 equals 0, 4x equals -3, x equals -3/4. Okay? Questions about this? So I showed you 3 today. First one, we divide our a out and then factor it. The second one, which is very similar to the third one, is we identify a perfect square and a perfect square. This is called a perfect square trinomial. And a perfect square trinomial works when you take the square root of this guy, times it by the square root of that guy, multiply by 2, and if it gives you your middle number, then it's a perfect square trinomial. If it's not a perfect square trinomial, then you have to go to the final one I just showed you. You have to identify difference of squares, and then if it's not factorable by taking the greatest common factor out, then you use your method here to do it. Okay? All right? That's all there is today with that. So you're just basically working on factoring again. So you're a complete review of grade 10. All right? Look at yesterday's work. For 7.4, is there anything in 7.4 that we had difficulties with?
On page 193, number 10B.
What is the equation of the function in factored form?
Yeah, are you just supposed to explain the coordinate or something?
They give you the coordinate. 1 and 18.
Like, I found the A part because it says that one of the functions is 4, so then I know that the vertex is exactly half of, or it's right between the two roots. So I found the other root.
Right.
But then for B, I don't know how to make an equation. Like, out of that.
Here's your equation.
Okay, right. So I guess I kind of understand that part, but how do you get an A out of?
I think.
I don't know, I got a -2 for,
How did you get it? What did you do?
I just used what I did for number 1, like, whatever the
What you're
in
supposed to.
between. Yeah, and then
And?
I just put it in for A, X, like, I don't know.
What are you given? You're given this. You're given this. You're given this. And you're given that.
Okay.
Look at your question.
Right.
It gives you an X and a Y. 1 and 18.
Right.
You got R. You found S.
Okay.
You have everything but A.
So,
You need to find A.
okay, thank you.
Okay? Anybody else? Questions with that? There's some good questions in there. I like it.
Can you go back to the second boy you showed us, like, when there's 2 perfect squares?
This guy?
I just, like, when you got 42x, what did you do from there?
Right here?
Yeah.
This is just my proof. I'm
Oh,
only
that-
using that just to make sure I can go this way. Because if I can't, Amron, then I have to go to there. Okay? But I use that as a quick proof just to make sure that it's a perfect square trinomial. Okay? Yeah, Brock.
I'm gonna do number 7 of 192.
Determine the quadratic function that defines the parabola. Yeah. Okay. All right, I like this question because it's testing you. All right, so this is what I have right here, Brock, right? Okay, what's your R value?
These are stands for
Your root,
-2.
-2.
Yeah.
Right, and because I have one of them only, R and S have to be the same thing.
Yep.
So, y equals a, x plus 2, x plus 2. Does that make sense?
Yeah.
Okay, now, when you only have one root, R and S are the same thing. If you look at that question, you see that it touches the graph and then goes up, right? Which means you only have one root in this case. Therefore, I put them in for both R and S. Now you pick a coordinate, Brock, off the graph. They give you another coordinate there. Put it in for X and Y and solve for A.
Okay.
Make sense?
Yep.
Okay. Yeah, Paige.
It's -2 on the graph. Why did you change it to +2?
It's X subtract -2. So X subtract the -2 is X
Oh.
add 2.
Okay.
Okay? Good question, actually. All right. Anybody else? Okay. You notice we're only going at about one section right now a day. So I'm expecting that you're doing a good job of this. We're not going ahead. We're just taking our time with it. We've got a bit of time here to get this 7 done. This is a biggie. So we want to make sure we get it done and done well. So let's make sure we get through all of 7.1 to 7.4. You've done all those questions, and then you get on to 7.5 today. Okay? No other questions, you get to work. Excuse me. Thank you.
And